the odds of somebody even remembering their dreams are so slim. How do you study that kind of
Yeah,
stuff?
about 95% of dreams are forgotten. So you
Right.
forget most dreams. And it has to do with the fact that during dreams, noradrenaline, as we said, shuts off. So the chemicals in the part of the brain called the nucleus ceruleus, 32 pitch black cell in the brain stem, these neurons shut down. So you don't have noradrenaline, right? But also there's another part of the brain called the raphe nucleus. And I'm not trying to act smart here by mentioning this name, but we know we have people that like to learn from the podcast as well, have to write some notes and maybe use it for their classes.
Right.
Raphe nucleus, interesting structure in the brain stem involved in producing serotonin. Because these two chemicals and these regions of the brain shut down during REM sleep, not only is our dream spacey, as we mentioned, but also you need these chemicals in order for the hippocampus, the memory part of the brain, to store down and store your memories, pretty much. Right. So this is
It's the save function.
This is sort of the save function. How do I take memories? So how do we save memories? You have the hippocampus, the C-like structure behind the ears. This part of the brain is involved in storing memories and taking the memories and storing them in the cortex, the outer layer of the brain. So that's where they're stored up here. The hippocampus is involved in accessing and storage, in placing them, let's say, not storage, but placing them. So this is very interesting. Because these two neurochemicals are absent in REM sleep, you cannot store dreams. You cannot store them. Now, you might ask, well, then how come we remember some dreams, and often you remember these dreams when, you remember the fraction of dreams you had, when you were just waking up from a dream. So let's say, but I'm sleeping right now. I wake up and somebody wakes me up. I'm jolted awake. And I remember about a fraction of the whole REM period.
Right.
So but I've been dreaming away the whole REM period. So you have REM for about, a third of the all sleep cycles is spent in REM. And during REM, you're actually dreaming the whole time. So in the 8 hours of sleep you have each night, hopefully,
Right.
a third of this is spent dreaming.
Right.
A whole third. But you remember only a few fractions of that, you see?
Right.
And that has to do with these two neurochemicals. The brain in a dream is it's not involved in storage, and it's not input fixated, but it's output fixated in the sense that it's involved in building stories rather than storing stories, if that makes sense. Because these two chemicals are absent, and another chemical called acetylcholine from the brain stem is hyperactivated. That's one of the excitatory chemicals that's hyperactivated. So the brain is always involved in creating narratives, building stories, building things versus storing them, which is these two other neurochemicals being absent. Is this clear?
It is. I mean, look, I feel like when it comes to the experience of dreams, which is where most people interact with dreams, it's my humble submission. I don't mean to cross a line in any way. I find that the physicalist explanation is sort of a for comfort. So if I take the adventure on and I climb the mountain of trying to understand what dreams or consciousness or human nature or any of this is, I can speak in the language of neurons and brain parts, and maybe there is a second order learning where I know, oh, this part is responsible for X and Y, and X and Y are therefore related, and that sort of magic happens. But for the experiencer of the dream, it's the experience that truly, accounts for what they're feeling. And so me personally, if I read a Jung or a Freud on dreams, it's much more interesting than reading a psychologist sometimes, because they'll also take it very seriously. And that's just, it's a literature fanatics way of understanding dreams. And so all of this is very clear. I completely understand. I feel like somebody who's listening, when they will try to understand, they'll still ask me the same question. Like, for instance, when I wake up, I feel like I was dreaming just right now. Like, it just seems like I was in another world and I just woke up. And I might have been stuck on that scene for an hour and a half. Maybe that happened 3 hours ago in my sleep. But it feels like it was the last, you know what I mean? Like, there's a discontinuity when I wake up.
Well, time is slowed down in dreams, right? Well, you've seen Inception, right? So in the movie Inception, there's this idea that our dreams is like 1,000 years in a dream, the same as like 5 minutes or an hour in real life. This idea of the proportionality of time and this time being slowed down in dreams. And it turns out, if you record from the neurons of mice, you record from neurons in the hippocampus. So they fire, and you record them. And then you record from the hippocampus. So you record while they're awake and while they are in REM dreams. And you find that the same neurons fire when they are awake, running through a maze. The same neurons are firing when they are in REM sleep. Same neurons. So this makes us go, wow, interesting, But here's the catch. They're about up to 50% slower in REM sleep. The same neurons, but they're about 50% slower, which is one of the key clues to the fact that this might explain why you sleep on your couch, you feel like it's been an hour, you look at the clock when you wake up and it's been like 5 minutes.
Yeah.
That's because potentially that time is actually, it feels like it's slowed down because the neurons are firing more slowly. So this is one of the evidences for that. Alan Hobson, do you know Ramachandran, by the way? V.S. Ramachandran. He's one of the top neuroscientists, Indian guy from Madras. He was one of my mentors, one of my closest friends for about, this is deep. So Ramachandran, I knew Ramachandran when I was a university student initially in like a bachelor's and all that.
Yep.
I was undergrad. I was in California. He was one of the top neuroscientists of the last 100 years. Great guy. And he was my mentor. He's one of my closest friends, and I learned from him. And he was the reason I got into science in the first place, really. And point of all this, beside bragging, is the fact that I wanted to do an experiment. We said, what if we have a guy and he's sleeping, right? He's sleeping in REM sleep, and then you sprinkle water on him. Okay, you sprinkle water on him. And and then a few seconds later, you wake him up. Okay? He's in REM sleep dreaming, and then you sprinkle water and then you wake him up. Here's the key question. You ask him, in your dream, what happened? Okay? There's two scenarios. Scenario one, he might say, I was walking in New York City, and then suddenly the clouds came out. I took up my umbrella. I called my mom. Mom, how are you? It's going to rain in an hour. And slowly the rain came. Okay? This is scenario one. Then there's scenario two. I was walking in the forest and suddenly I was hit by a tsunami. Water hit me. Okay? This is scenario two. Mind you, when I sprinkled water on this poor chap sleeping, I woke him up almost instantaneously, like a few seconds later. Would he have enough time to incorporate the water into his dream? This is the key question. We already know from neuroscience that you will incorporate things from the external environment into your dream. We know that. So if you're sleeping in a room and it's cold, you will feel like you're in Iceland and there's an ice bear and things like that. We know this. Or if you are in a room and there's a lot of smoke, you might feel like you are in a fire situation.
Right.
We already know this is known. Now the question is, what about this guy? What happened to him? We don't have the answer to this question, but it could reveal a lot of things about dreams.
And so, when you ran the experiment, did these people report the incorporation of water?
We didn't run it.
Oh, you did not run this?
We wanted to run it. And I took this experiment to Alan Hobson, the dream researcher, from Harvard Medical School. I took it to him and I said to him, look, we want to do this experiment. What do you think? And he said, this is huge experiment. It's going to be big. But you're forgetting one thing. When you are sleeping, the thing is you are paralyzed, and you also have sensory systems. This has to do with the brainstem. You cannot really, if you put water on the person while he's dreaming, you'll either wake him up or it might not be enough to incorporate that. It might not be enough stimulation. It's a very tight line. You understand? This is a very technical point. Too much water, the part
You'll wake them up.
You wake him up.
Right.
Too little water, maybe it's not enough to stimulate him.
Right.
He had an idea. He said, this is a very good, interesting experiment. There's something called TMS. You stimulate a part of the brain and you activate it temporarily.
This is transcranial magnetic stimulation.
You put it on the brain, zap it, zap it. So you might do that to the somatosensory regions, meaning there are regions in the brain that's, when you activate it, it can actually activate your sensory systems. This is one way to get around this experiment. But it's the actual answer to the experiments is, I think, very crucial. It tells us about time perception of dreams in humans. And it hasn't been done yet, to my knowledge. This was a few years ago.
Can I offer you an alternative that's going to sound stupid and you tell me why it's so stupid?
Go ahead.
This happens if somebody's ever wet their bed as an adult. Somebody ever has wet their bed as an adult. you go into a situation where, like, in your dream state,
Mm-hmm.
you are going to pee, right? Like the narrative construction in
It's
your
gonna
dream
pee,
is
exactly.
you are going to the bathroom,
Absolutely.
and then something happens on the other end, and you wake up because it's all wet. So you do incorporate at least, like, that's an experience I remember from when I was 12 or 10 the
Same
last
here,
time.
same
Yeah, right.
here.
Like, you remember that experience because
You
you're
do,
like, wow.
It's kind of embarrassing too, right?
It's, I mean, whatever. We're talking about very intellectual stuff here, by the way. The embarrassment's been left outside the door, as far as I'm concerned. But I mean it, like, it's a natural experiment because your body still has to excrete, so you don't have external stimuli per se.
Yeah.
It's going to happen regardless. And
Yeah.
then maybe there is an account for the fact. Plus, it's so emotional because of its embarrassment that the odds of people remembering their dream might be more.
Yeah.
Because the emotional charge in the dream is more.
100%. 100%.
How stupid is my idea?
No, it's very interesting.
Yeah?
That's not stupid at all.
Yeah,
It's very interesting.
But it'll be hard for you to stimulate somebody's prostrate when they're asleep. For them to actually pee, it's going to be really like, how do you get to that spot,
Exactly.
right? Like,
Exactly.
But it's a natural experiment regardless.
It is very interesting.
Yeah.
Well, you're Indian. You have good experiments.
Thank you, man.
Very good, man.
Yeah, we've run quite a few in our country.
Very interesting.